All right, Mikey, yes, I'm using a Lucky Charms box to prop this video up. Anyways, the thing that we didn't get to cover in 1-3 was the rational number system. So I was drawing a picture on the board when we got frozen. So this side is the irrational numbers. This side is the rational numbers. And the whole thing is called the real number system, okay? Now, in the irrational is square roots of non-perfect squares and pi. That's it. And the rational side is numbers, so like 3 or -7 or 2 1/2 or -1.7 repeating or 1.22. So basically all the numbers that you know are rational. But inside the rational number system are our integers, and integers are positive and negative counting numbers, so like -2, 7, 1, okay? Whole numbers are inside of that, and whole or positive counting numbers including 0, so like 0 or 3. And then the smallest group is the natural numbers, so nat means natural. Move this up a little. Okay, and those are positive counting numbers not including 0. Okay, so if it tells you to name the subsets, that's what it's asking you to name, where it fits in this real number system. So like if I said to name -3 based on subsets, okay, you would think, okay, -3, that is a number that I could count to, -1, -2, -3. So natural numbers are positive counting numbers not including 0. Well, that's -3, so not that one. Whole numbers are positive counting numbers including 0. It's negative. Integers are positive and negative counting numbers, so this is an integer. And then rational numbers are any number that can be made into a fraction. This could be made into a fraction by putting it over 1. So this is also rational. And that would be all you have to write. Another one would be like 1 3/4. Okay, 1 3/4. Is that a number that you would typically count by? No. So that knocks out natural, positive counting numbers, not including 0. That knocks out whole, positive counting numbers, including 0. Integers are positive and negative counting numbers. So rational are any numbers that can be made into a fraction. And it's a fraction, so this is rational. The square root of 16. All right, what is the square root of 16? It's 4. All right, so 4, is that a counting number? 1, 2, 3, 4? Yes. Is it a natural number, a positive counting number? Yes. So I'm gonna put nat for natural. Is it a whole number, a positive counting number including 0? Yes, it's a positive counting number. Is it an integer, positive or negative counting numbers? Yes, it's a positive counting number. Is it rational, any number that can be made into a fraction? Yes. And you will find after you get going on these, well, you can see that that's rational. After you get going on these, if something is natural, it's automatically whole, integer, rational. If something's whole, it's automatically an integer or rational. If something's an integer, it's automatically irrational. Okay, so that's how that kind of works. All right, last one like this, the square root of 15. All right, what is the square root of 15? It's like 4 point blah, blah, or 3 point blah, 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 okay? There's no repetition in that. This is a square root of a non-perfect square. 15 is not a number that's been squared. So this one is irrational. Irrational. All right, moving on to 1-4. In 1-4, we talked about the properties of the real number system. So our 4 properties are the commutative property, and the commutative property says that you can add or multiply in any order, and the answer doesn't change, okay? The associative property says that you can add or multiply in any order, but you have to regroup parentheses. Okay. That's associative. Okay, and then we have the identity property. The identity property says that you add 0 or multiply by 1 and it's still the same number, because anything plus 1 is still itself, anything times 1 is still itself. And then we also have the 0 property that says multiply by 0, it always equals 0. Okay, So I'm going to write something here, and you're going to tell me which property it is. So 3 plus 7 is equal to 7 plus 3. This is the commutative property because I can add in any order, and the answer is still the same. Three times 1 equals 3. That is the identity property because anytime that you multiply by 1, it's still the same answer. So identity. 5 times 0 equals 0. Well, anything times 0 is 0, which is the 0 property. And then 3 times 7 times 2 is equal to 3 times 2 times 7. This one is the associative property because I regrouped with parentheses. That's the difference between commutative and associative. They're exactly the same, that you can add or multiply in any order, but associative will take what's in the parentheses and regroup it, put different numbers in there. Okay, so that was one thing that we did in 1-4. We also combined some like terms. So they're just going to say simplify. Okay, so they'll say like 3 times 7 times n. And you have to put together like terms. So I can multiply numbers here. So 3 times 7, that's 21n. Or if they say 2 times 6x. Well, that's 2 times 6 times x. I can multiply the 2 and the 6. 2 times 6, that's 12x. Or with their adding, they could say 3 plus x plus 4. Well, I can put together like terms, which are the numbers. 3 plus 4, that's 7 plus x. Because x and 7 cannot be put together because they're not like terms. In order to be like terms, they have to have the exact same variable on them and the exact same, or just a plain number in general. So 7 plus x would be my answer there. Or like if they put 2 plus 5 plus 3x. Well, 2 plus 5, that's 7. So 7 plus 3x. And I can't put those together once again because 7 and 3x are not like terms. These are like terms because it's multiplication, and you can multiply things that are different. But when you're adding and subtracting, they have to be either plain numbers or both have x's on them to be like terms. All right, and then the last thing that we did in 1-4 was something called deductive reasoning. So I'm going to talk here just for a second. So deductive reasoning is basically the reasoning process in your head that logically comes to conclusions. So if I said, it's dark outside, there's a lot of clouds, there's lightning, there's thunder, we can predict that it's going to rain. That's deductive reasoning, coming to a conclusion logically. Now, in math, they're going to give you some type of example of math and have you use deductive reasoning to figure out if it's true or false. Now, here's where we're going to go in a little bit more math. We're going to do something called a counterexample. Basically, a counterexample is an example showing something is false, okay? Something is false. So in the real world, I would say all people with brown hair have brown eyes. Well, I bet you somewhere somebody is brown hair with blue eyes. They would be the counterexample to my statement. Or if I said all brown-haired people own a rabbit. Well, guess what? I'm my own counterexample because I have brown hair, but I don't own a rabbit. But in math, they're going to give us something like A plus B is equal to A times B. And they're going to say, is this true or false? And then it's going to say, if it's false, give a counterexample. So A plus B equals A times B. Well, we can look at it and determine if it's true or false. If you don't know if it's true or false, plug numbers in, but do not choose 0, do not choose 1, choose any other number. So how about I choose 2 and 3? So I don't know if it's true or false, so I'm going to say 2 plus 3 is equal, and I said A was 2, so 2 times 3. Well, what is 2 plus 3? 5. 2 times 3 is 6. Are those equal? No. So this is a false statement, and this is my counterexample. This is an example showing that it's false. Okay? How about j times 1 is equal to j plus 0? If it's true, write true and you're done. If it's false, you gotta give me a counterexample. If you don't know if it's true or false, choose a number to plug in. So let's say I wanna make j 5. So 5 times 1 is equal to 5 plus 0. 5 times 1 is 5. 5 plus 0 is 5. Are those equal? Yes, so this is true. All right, hopefully this helps. Email me if you have any other questions and we'll go from there. Thanks, bye.